In a previous video, we looked at finding the symmetry of a function's graph. And if we have the graph, it's pretty easy to determine what that symmetry is going to be by just looking at it. But what if we have the equation of the function rather than the graph itself? And it turns out that we can still determine some symmetries by determining whether or not the function is odd, even, or neither. So a function is said to be even if f of negative x is equal to f of x for all x in the domain of f. And if the function is even, then the function's graph is going to be symmetric with respect to the y-axis. A function is said to be odd if f of negative x is equal to negative f of x for all x in the domain of f, and an odd function's graph is symmetric with respect to the origin. And then if neither of these is true, if f of x does not equal f of negative x, and if f of negative x does not equal negative f of x, then a function is said to be odd. Neither even or odd. And in that case, then the graph is not symmetric with respect to the y-axis or the origin. So let's look at an example of where we are determining whether a function is odd, even, or neither, and then using that to determine the symmetry with respect to the y-axis, the origin, or neither. When we have the function's equation, the way to determine whether or not the function is even, odd, or neither is to find f of negative x and negative f of x if needed, and then determine which of those, if any, are equal. Because we already have f of x, and we know that in order for it to be considered even, then f of x has to equal f of negative x. So what we need to figure out is what is f of negative x for this particular function. So to do that, we're going to go back to our knowledge of how to evaluate a function. So we're going to plug negative x in. So we get negative x cubed minus 6 times negative x. So f of negative x is actually equal to a negative x cubed, because a negative times a negative times a negative would be a negative, and then just x cubed. And then a negative 6 times a negative x would be a positive 6x. So the first thing we're going to ask ourselves is, does f of x, which was x cubed minus 6x, does that equal f of negative x? And it's easy to see there that the answer is no, because the signs are different on both terms. So that tells me that this function is not even. So now let's go ahead and test to see whether it's odd. Well, if it's odd, then f of negative x, which we just found, will be equal to negative f of x. So let's find negative f of x and determine whether or not these two are equal. So we're making the entire function negative, so we're putting a negative in front. Don't forget to put it in parentheses so that we remember to distribute that negative to each term. And we end up with a negative x cubed plus 6x. And again, if we compare f of negative x with a negative f of x, you can see that they are identical, they are equal, and that tells me that this function is odd, because when f of x, or negative f of x equals f of negative x, then the function is odd. And that also tells me that it is symmetric with respect to the origin. And the way I like to remember that is O and O. So odd O, origin O. Now let's move on to our next example, where we have g of x equals x to the fourth minus 2x squared. Again, the first thing I'm going to test for is to see if it is even. So I'm going to find g of negative x and see if those two functions are equal. So I have negative x to the fourth power minus 2 times negative x squared. So remember, a negative to the fourth power would be a negative times a negative times a negative times a negative, which would be a positive. And then we have x to the fourth. Then we have a negative x squared times a negative x times a negative x, which would be a positive x squared times a negative 2, which would be negative 2x squared. And we can see that g of x is in fact equal to g of negative x in this case, which tells me that the function we are working with is even, and that means it is symmetric with respect to the y-axis. So if we are given the equation of the function, all we have to do is plug in the negative x or negative f of x and test to see if they are equal. If, however, we are given the graph, well, we can still determine whether or not it's odd, even, or neither just by looking at the symmetry of the graph. So remember, if it has symmetry with respect to the y-axis, then it's going to be an even function. If it has symmetry with respect to the origin, it's going to be an odd function. And if it doesn't have either of those symmetries, it's going to be neither. So we can look at this one and see that it doesn't have symmetry with respect to y, because if I were to draw a line on the y-axis and I were to fold that in half, the two halves would not match up. And if I were to flip it upside down, it would end up looking more like an M than a W. So that means it's not symmetric with respect to the origin. So that tells me that it is neither odd nor even in this case. Now, quickly let me point out that all we would have to do is shift it one place to the left, and then we would have something that was symmetric to the y-axis, because then it would look like this, and then everything would match up if we folded it on Y. But because it's not shifted over in this case, it is neither.